Hello, friends. Here we are, 7.2, and we're going to graph those rational functions differently than how we graph just the transformation of the parent function like we talked about last class. So this is going to be a whole new process like I talked about. And really, there's four things that we need to seek out, four pieces of information that are really important to get in that graph of the rational function. And so we're going to focus on those four parts first and finding those before we actually throw it all on a graph. So what we need to do to find these four pieces of the rational function in order to graph is we always need to factor first. Remember, these rational functions are polynomials divided by other polynomials. So we need to factor the top and we're going to factor the bottom. Once we have it factored, then we can find these four pieces: the vertical asymptotes, the horizontal asymptotes, our X-intercepts, and our Y-intercepts. So remember, vertical asymptotes are what, if you think back to when we transformed the original parent function, that was based on our shift left and right, and that affected the domain, right? That's where those x values had to stop. They couldn't touch or cross those vertical asymptotes. So these vertical asymptotes are restrictions on our domain. And how do we find that? Well, remember with the parent function, we got that vertical asymptote by plugging in 0 for x and getting that undefined value. Because remember, any number divided by 0 is undefined. And that undefined is the slope of a vertical line. Remember, vertical lines have undefined slope. So to find our vertical asymptotes, we're actually just going to set our denominator equal to 0. Okay? And that's it. So if our denominator is like x plus 3 and x minus 5, then we're setting those two factors equal to 0. So our vertical asymptotes would be at x equals negative 3 and x equals positive 5. Yes, it is possible to have more than one vertical asymptote. Most of the time in this set of notes, we're going to see one for the majority of the time, but we will do some examples where they have two. So vertical asymptotes, we're going to set our denominators equal to 0. Something silly that my classes and I kind of thought about last year was that when I saw vertical asymptote, the little acronym I use for it, VA, for some reason I always thought of vampires for some, I don't know, strange reason. And so I would always ask, well, where do the vertical asymptotes live? Where do we look for those vertical asymptotes? And because it's in the denominator, and because I was thinking about vampires, it came to our conclusion that we would say, well, the vampires live in the basement. So the vertical asymptotes live in that denominator. We want to set that denominator equal to 0. Okay. Horizontal asymptotes. Remember, again, how we transform the parent function. Horizontal asymptotes are based on any shifts up or down. And so that affected our range and that affected our end behavior. So this time, because we have those polynomials divided by one another, we're actually going to compare the degree of our numerator, the top, and the degree of our bottom, the denominator. So remember back in Unit 5 when we were dealing with polynomials, the degree of the polynomial when it's written in standard form is that highest exponent. If you've already factored it, remember you're adding up the multiplicity or the exponent of each factor to get the degree of the polynomial. So three things could happen when you're comparing the degrees of your the top and the bottom polynomials. You could either have the bottom bigger than the top, so we would call that bottom heavy, where the degree of the denominator is bigger than the degree of the numerator. You could have equal degrees, so the same degree in the numerator and in the denominator, or you could be top heavy, where your numerator would have a bigger degree than your denominator. If you are bottom heavy, if the degree of the bottom is bigger than the degree of the top, quite simple, your horizontal asymptote will always be y equals 0. Always. You don't have to do any math. If the degree of the bottom is bigger than the degree of the top, y equals 0. Now, something silly again that we talked about last year of how we remembered this. When I saw that term bottom heavy, my brain went to big butts, right? So then I thought about, well, what famous actress or pop star has a really big butt and is known for their big butt? And that was J-Lo. And so I think bottom heavy, big butt, J low, Y equals 0. J low, Y equals 0. Okay, it also helped that last year J Lo was the Super Bowl halftime performance. Show. It was all about her and Shakira. So anyway, they just kind of fit. But now it just stuck in my head. J low, Y equals 0. Bottom heavy. If the degrees are equal, this is actually pretty easy too. You're going to have to do a little bit of math, but it's super easy. What you're going to do when you have equal degree is you're actually going to divide your leading coefficients. So that is going to give you, you're going to divide, let me move this over. You're going to divide those leading coefficients. So the number that you get is that horizontal asymptote. You're dividing the leading coefficients. And that's going to get you your Y equals that number. It might be 3 divided by 1, which is 3. It might be 2 divided by 4, which is 1/2. Whatever. But that's going to get you your horizontal asymptote. If it is top heavy, it actually does not have a horizontal asymptote. So if it's top heavy, if the degree of the top is bigger than the degree of the bottom, there is no horizontal asymptote. Now, in our next lesson in 7.3, we actually talk about if the degree of the top, if the top is exactly 1 degree higher, then we can have something called a slant asymptote. Okay, so instead of on a graph, instead of it being horizontal, it would be slanted. Pretty cool. We're going to talk about how to get those slant asymptotes, like I said, in 7.3, which is just an extension of what we're doing today. Okay, but for today's purpose, if it's top heavy, we just say no horizontal asymptote. Okay, so 3 things there. Bottom heavy, J low, Y equals 0. Equal degree, you're going to divide the leading coefficients by each other, and that is your horizontal asymptote. And if it's top heavy, it doesn't have a horizontal asymptote. I'm going to go to my intercepts next, X-Intercept and Y-Intercept. Now, these are terms that you've known pretty much all of your mathematical life, like middle school to high school, right? Any function that we've been dealing with, we have found our X-intercepts and our Y-intercepts the exact same way. And that's based on what those look like as ordered pairs. The X-intercept as an ordered pair, think about it, it's where it crosses the x-axis. So it's going to be some number, comma, 0. And the y-intercept is obviously 0, comma, some number. So we need to think about that and use that to our advantage. If I have an x-intercept, that means what is giving me 0 as that y value? Well, if I have y equals some polynomial divided by another polynomial, how do I get 0 over here? Well, that means I have 0 divided by any number. So I don't actually care what's happening in the denominator. All I'm focused on is that numerator and setting it equal to 0. Okay, so we're actually going to set numerator equal to 0. That's Junebug. She says hi. And that's because 0 divided by any number equals 0. And that's June. She's sad because she can't come in where I'm at. So remember, that's because for an x-intercept, we want it to look like some number, comma, 0. 0 for that y value. Okay, and that's how we're going to write our x-intercepts and y-intercepts. We're going to write them as ordered pairs. For the y-intercept, again, just like we've been doing your whole mathematical life from middle school to high school, the y-intercept looks like 0, comma, some number. So that means we are just going to plug in 0 for x. And we're going to plug it in for every x of the function. Okay, sounds like it's a lot of work, but it's really not once you have it in factored form. Or actually, when it's in standard form will be the easiest, and I'll talk about why. The last thing we want to talk about is when it comes to actually graphing. Once you have these 4 pieces of information, we're going to then put it on a graph. Well, you're going to explore that rational functions are going to look very different. Every single rational function looks extremely different than the others. A lot of them have the same characteristics, but all of them look different. It's depending on these four characteristics. And so I want to talk about what happens whenever we have some squared factors. So if we have squared factors, that could either happen, that could either happen at the top or it could happen at the bottom, numerator or denominator. If it's happening at the top, remember our top is where the X-intercepts live. Remember, we're setting our numerator equal to 0 for those tops. So let's imagine I have some polynomial and I factored it and I have x plus 3 squared, x minus 1, and x minus 5 squared. That's my numerator, okay? Well, I know that these X-intercepts would be at -3, +1, and +5. Well, just like our unit for polynomials, you could also then tell me what's happening at -3, at 1, and 5. You would tell me at -3, you would be bouncing because that has a even multiplicity. You would tell me at 1, you would be crossing because it has a multiplicity of 1. And you would tell me at 5, you would also be touching or bouncing because it has that even multiplicity. The same thing happens here. Excuse me. So if we're only talking about squared factors, so if we have a squared factor in the numerator, it's going to cause that bounce or that touch at the X-intercept. Bounce, I'll put at X-intercept, okay? If the factor in the bottom is squared, in the denominator is squared, remember, who lives in the denominator? That's the vertical asymptotes. We're setting that denominator equal to 0 to get those vertical asymptotes. So when I have a squared factor in my denominator, this means that the graph is going to go towards that vertical asymptote together. Okay, so maybe an example of that on a graph. Let's say I have a vertical asymptote here. Let's pretend that that is something divided by x minus 4 and it's squared. So if I set my denominator equal to 0, then that means I would get x equals 4 as my vertical asymptote. So that's here. And because it's a squared factor, maybe my graph is going to go towards that vertical asymptote up here, or it could go towards that vertical asymptote down here. Whether it's up or down is going to be dependent on the other things present. Any horizontal asymptotes, any X-intercepts, Y-intercepts, etc. Okay, but that's what it's going to physically look like. They're going to be approaching that asymptote together. Okay, so that's where that tangent or that togetherness comes from. All right, so let's see if we can slowly start putting all these pieces together. So if we notice example 1 is strictly focused on finding the horizontal asymptote. So remember, we're looking at we're comparing the degree of the top and the bottom. So we're going to determine if it's bottom heavy, equal degree, or top heavy. No need for us to factor it out for just finding the horizontal asymptote unless you want that practice, because as you guessed it, you're going to be factoring a lot. Okay, and you're going to have to do it precisely and quickly. So if I'm comparing the degree of the top and the bottom, because A is in standard form, the degree of the top is 4, and the degree of the bottom is also 4. Because they're equal degree, I'm going to divide my leading coefficients. So this means I have y equals 8 divided by 2, which gives me a horizontal asymptote of y equals 4. In my second problem, the degree of the top is 2 because 1 plus 1 is 2. The degree of the bottom is 3 because 2 plus 1 is 3. So if the degree is 2 over 3, that's bottom heavy. The degree of the bottom is bigger. J low, y equals 0. And lastly, in C, it's in standard form again. The highest degree up top is 5. The degree of the bottom is 4. This is top heavy, so no horizontal asymptote. Because it is exactly 1 degree higher, it will have a slant asymptote. We'll talk about that more in detail in 7.3. This is all we're focused on today. All right, now let's take it a step further and find both the horizontal and the vertical asymptotes, both my X and Y intercepts, and that will also allow us to figure out our domain. Okay, so now it is very important that we do factor first because we're finding vertical asymptotes, X-intercepts, Y-intercepts. All those things are going to be easier for us, or most of them will be easier when it's factored. And like I said, we need to get our practice in. So first thing I want to do is factor. So I'm going to factor. First steps in factoring, GCF. So the numerator, that's going to give me 2 times x squared minus 9. That's the difference of squares. So that's 2 times x plus 3 and 2 times x minus 3. I'm sorry, 2 times x plus 3 and x minus 3. In my denominator, my leading coefficient is not 1, so I need to multiply a times c, so I need factors of negative 24. That's going to add up to a positive 5, and that is going to be 8 and negative 3, so I want to rewrite this. And then I'm going to factor by grouping, so this is going to be... I'm just going to work out and erase my work afterwards. So this is going to be 2x times x plus 4. This is going to be negative 3 times x plus 4. The factors inside the parentheses are the same, so that makes me happy. So this gives me 2x minus 3 times x plus 4. So I'm going to erase all my work. That way I can have room for everything else. And I can go ahead and make this a little bit smaller and bring it up here. Perfect. And so now I can focus on finding my vertical asymptote, my horizontal asymptote, my X-intercept, and we'll go with yellow, Y-intercept. Okay. So vertical asymptotes, we set our denominator equal to 0. So my denominator is 2x minus 3 times x plus 4. When I set the factor of 2x minus 3 equal to 0, I add the 3, divide by 2, so I get x equals 3/2. That is a vertical line. I also need to set x plus 4 equal to 0, so that means I get x to be negative 4. So 2 vertical asymptotes here. Horizontal, remember we compared the degrees of the top and the bottom. The degree of the top was 2, the degree of the bottom was 2. So because they're the same, I'm going to divide the leading coefficients. The leading coefficients are 2 and 2, so that means my horizontal asymptote is at y equals 1. My x-intercepts, I find those by setting my numerator equal to 0. And remember, I want to write these as ordered pairs. So an x-intercept is going to be some number, comma 0. So if I set my numerator equal to 0, 2 equals 0 doesn't give me an x-intercept, but x plus 3 equals 0 means I have an x-intercept at negative 3, comma 0. And then I also have one at 3, comma 0. And then for y-intercepts, I plug in 0 everywhere I see an x. This is actually a time where using your standard form would be a little bit easier for you. Because if I plug in 0 here, here, and here, in my numerator, I'm just getting a negative 18. And then in my denominator, 0 plus negative 12 is just negative 12. And so then that reduces, and that gets me a y-intercept of 0, comma... that reduces to 3 over 2, both divisible by 6. Okay, so a little bit easier. You can get the same answer by plugging it into the factored form, but you'll have to do a little bit more math. Okay, and then it does ask for the domain here. And so remember what affects the domain. The vertical asymptotes affect the domain. So the domain here would actually be from left to right, negative infinity to negative 4, stop at negative 4 because that's a vertical asymptote, all the way to that 3/2, which is the other vertical asymptote, and then finishing out to infinity. Okay? In our next lesson, we're also going to talk about another thing that would affect your domain. But as of right now, it's only vertical asymptotes that affect it. Let's go on to the next one. In part B, I don't need to factor my top. It's just that constant value of 7. But I clearly need to factor the bottom. And so because there are 4 terms, I can factor by grouping. And so I'm going to pull out a 9x squared, leaving me with x minus 3. And then a minus 4, leaving me with x minus 3. So now I have 9x squared minus 4 times x minus 3, which gives me 3x plus 2, 3x minus 2, and x minus 3. Okay, so I'm going to erase my work so I have more room. All of this is divided by, or being divided by 7, or 7 is, whatever, you know what I'm talking about. Okay, so then I'm going to move this up here. All right, and then I go back to what I need to find. Vertical asymptote. I am setting my denominator equal to 0. So because I have those 3 factors, that kind of tells you something. That's going to mean that I'm going to have 3 vertical asymptotes. The first one is a negative 2/3. The second one is a positive 2/3. And the third one is at 3. Horizontal asymptotes. We are comparing the degrees of the top and the bottom. The degree of the top is technically 0. And the degree of the bottom is 3. So that clearly means it's bottom heavy, big butt, J low, Y equals 0. Then I'm going to go to my X-Intercepts. So I'm setting my numerator equal to 0. Well, 7 doesn't equal 0, therefore there are no X-Intercepts. And then lastly, my Y-Intercepts. I am plugging in 0 everywhere I see an X. This time it's going to be easier to plug it into that standard form. That way I get 7 divided by 0 minus 0 minus 0 plus 12. So that's 7 over 12. So that means as an ordered pair, that's going to be 0, 7 over 12, and that doesn't reduce. So that is my Y-intercept. And now I can find the domain, which remember only the vertical asymptote is affecting the domain for right now. I want to make sure I'm going in order from left to right. So negative infinity all the way to the negative 2/3. Negative 2/3 to the positive 2/3, positive 2/3 to 3, and 3 to infinity. Yes, I know that's very long and drawn out, but you have to stop at every vertical asymptote because you cannot cross or touch those vertical asymptotes, so that affects your domain. All right, we have one more to do. So we're going to factor the top. So I need to pull out my GCF of 2x, leaving me with x cubed minus 8. What you see inside the parentheses is now the difference of perfect cubes, which then is going to become x minus 2, and then we scums it, square, change the sign, multiply, square the last. Okay, remember we're never going to be able to factor this any further, and also remember that trinomial, because it's not factorable, is always going to give us an imaginary solution, and that's going to help us out in just a little bit. I also now want to factor this bottom, the denominator, and so I want to treat this like a normal trinomial because it is fourth and then squared and then a constant, so that's fine. So I need factors of negative 70 that add up to negative 3, and so that's going to be 7 and 10, and so we want a negative 10 and a positive 7. So I'm going to rewrite this as 2x to the 4th minus 10x squared plus 7x squared minus 35. Factor by grouping, that's going to give me 2x squared, leaving me with x squared minus 5. And then I'm going to take out the plus 7, leaving me with x squared minus 5. So that means I get 2x squared plus 7 times x squared minus 5. Neither one of those can be factored any further. I'm going to erase my work and make this smaller, bring it up to the top. All right, and so now I find all the characteristics. Vertical asymptote. Set your denominator equal to 0. Well, when I set 2x squared plus 7 equal to 0, I'm technically subtracting dividing, and then I have to take the square root. Can I take the square root of a negative number? No, it's imaginary. We're not going to be dealing with that right now. If it's imaginary, it doesn't exist. So no vertical asymptotes are coming from this factor. But I also have another factor of x squared minus 5. Set it equal to 0. X squared equals 5. X is equal to the positive and the negative of the root of 5. Please be careful when you're taking the square root of numbers that you include both the positive and the negative. So technically we have a vertical asymptote at x equals positive root 5 and a vertical asymptote at x equals negative root 5. So still two vertical asymptotes. Now we go to horizontal asymptotes where we are comparing the degree of the polynomial. The degree of the top is 4. The degree of the bottom is also 4. So we're looking at those leading coefficients. 2 divided by 2 is 1. So our horizontal asymptote is y equals 1. Then we go to our x and y intercepts. X-intercepts, remember we are setting our numerator equal to 0. So technically I have three factors that I can set equal to 0. 2x, when that equals 0, x is 0. So that's going to give me an x-intercept of 0, 0. X minus 2 equals 0 would give me an x-intercept of 2, 0. But remember, when I set that last factor equal to 0, I'm technically solving that trinomial, which is not going to be real because it's not factorable. It's an imaginary answer. And if you don't remember that, if you don't believe me, plug it into the quadratic formula. You're going to get some imaginary solutions, which means they are not physically there so that there's no other x-intercepts other than 0, 0, and 2, 0. And then we plug in 0 for x, to find that y-intercept. Again, I'm going to go to my standard form because when I plug in 0 here and 0 there, my numerator is just 0. And when I plug in 0 at the bottom, I get negative 35, but 0 divided by any number is 0. So that means my y-intercept is 0, 0, which makes sense because if I have an x-intercept at 0, 0, then obviously my y-intercept needs to be there as well. And so then lastly, we can put it all together for our domain. And this time we just have two vertical asymptotes to take into consideration. We have the negative root of 5 to the positive root of 5 to infinity. Okay. And now we take all this and we throw it on a graph. Okay, we're going to start off pretty simple and then we're going to get a little bit more and more complex. So what we want to do is we want to find our asymptotes and our intercepts and then put that on a graph to see where it's going to end up. For vertical asymptotes, remember we're setting our denominator equal to 0. Lucky for us, part A is already factored, so we don't have to do that first step of factoring. So vertical asymptote, we're going to set the denominator equal to 0, so that means our vertical asymptote is at x equals 1. I'm going to go ahead and plot that right now. I'm going to always use a dashed line or a dotted line, depending on what you prefer, for the asymptotes. And thankfully, Notability has that feature now built in for us, which is so cool. Okay, now we have horizontal asymptotes. Horizontal asymptotes are when I compare the degree of the top and the bottom. The degree of the top here is 1. The degree of the bottom is also 1. So because they're the same, I divide my leading coefficients. 2 divided by 1 is 2. So my horizontal asymptote is at y equals 2. Now I want to find those intercepts, the x and the y-intercepts. X-intercept, I plug my numerator or set my numerator equal to 0. So when I set 2x minus 3 equal to 0, I get 3 halves. Oops. Remember, I want to write these as coordinate locations. So that's 1.5, 0. So that's going to be somewhere about right here. And then for the for the y-intercept, I'll keep the same color. I plug in 0 for x. So that would be negative 3 divided by negative 1, which is positive 3. So 0, 3. So remember, like in our transformation of the original parent function, we typically either had things in quadrant 1 and quadrant 3, or in quadrant 2 and quadrant 4. They were kind of always the opposite of one another. We're going to see that that's not always the case, but for this problem, it has to be because of the location of your intercepts. I have an intercept here, so that means I need to approach the asymptote here and approach the asymptote here. And then for my y-intercept, approaching the asymptote and approaching the asymptote there. Okay, and remember, you can always pick other points just to get an idea of where you're at, but for this one, it's pretty easy enough to just go off of those x and y intercepts and using those asymptotes to help guide you. Okay, also we need to remind ourselves now that we are going to take this characteristic into consideration. So anytime we have a squared factor, whether it's on the top or the bottom, it is going to affect our graph. So we need to remember that. We hopefully are pretty comfortable now with finding the 4 characteristics of vertical, horizontal asymptotes, x-intercepts, and y-intercepts. So now we need to throw in that 5th kind of reminder or something to think about. Okay, B is not all the way factored, so that's the first thing that we want to do. So 1 over factors of 9 that add up to -6 are going to be -3. And this is actually going to be a squared factor, right? This is a perfect squared trinomial. So already in my brain, I know I have a red flag because of what I just said. If there's a squared factor at the top or the bottom, we're going to have to deal with either a bounce at the x-intercept or the tangent or togetherness going towards that vertical asymptote. Well, because we already know we have a squared factor in the bottom, we know that that's going to affect this vertical asymptote. Okay, so let's go ahead and find that vertical asymptote. Setting our denominator equal to 0, we're going to get x equals 3. And because it's squared, we're going to say this is a tangent / together. Okay, whatever note you want to make there, just so you don't forget when you go to graph it. So because when I graph it, all I'm seeing right now is this. So we don't see that tangent or togetherness until we actually physically graph after we have all these characteristics. Okay, now we have our horizontal asymptote. Horizontal asymptote, you're comparing degree. The degree of the top is technically like 0. The degree of the bottom is 2, so it's bottom heavy, J low, Y equals 0. X-intercepts and Y-intercepts. X-intercepts set your numerator equal to 0. Well, that's not possible here. So there are no X-intercepts. Y-intercept, you plug in 0 for X. Excuse me. So that means plugging in 0 here and 0 here, I get 1 over 9. So if I had to plot that, I would be right above that horizontal asymptote. Okay. Well, that y-intercept actually helps me because that means I know I need to approach this vertical asymptote and approach that horizontal one. Because that vertical asymptote had a squared factor, I'm not going to go down here for my other part of the graph because I know that I need to approach the vertical asymptote together from the same side. So that's why I know now that the other part of this graph is in like that first quadrant that we've created. Okay, I know this is weird right now, but the more practice you do, and whenever you do a Desmos activity that I'm going to post later on, you're going to kind of see that everything kind of comes full circle. Okay, so let's just keep on going and keep on practicing because that's how we get better, and that's how we make ourselves aware of the different types of graphs that we can create and that we can see. Always remember to factor first. Luckily here, we don't have to factor the top, but we do need to factor the bottom because that's the difference of squares. So that's going to be an x plus 3 and an x minus 3. And so now that we're all factored, we can find our characteristics. Vertical asymptote, we're going to have 2, x equals 3 and x equals -3. So if I plot that right now before I forget, I'm going to have it at, I need to blow that up. -3 and +3. So here's one where we're going to see 2 vertical asymptotes and how that maybe affects our graph. This is the first time we see it possibly. Now we're going to go back to find our horizontal asymptote. So comparing the degree of the top and the bottom. This one is bottom heavy, J low, y equals 0. So then graphing that horizontal asymptote here. Okay. And then lastly, finding those X-intercepts. So X and Y-intercepts. X-intercept, setting our numerator equal to 0. So we have 1, 0. Right here. Red flag might be going off in your brain. That's okay. Good thing. But here's the kicker. You can actually cross and or touch the horizontal asymptotes. I know, kind of crazy. You will never cross or touch a vertical asymptote because remember, that's when your denominator is 0. There's never a time where dividing by 0 gives us a number. It's always undefined. But there are times where I can plug in certain x values and get y values of 0. And so that is why we can touch or cross the horizontals, but we can never cross or touch the verticals. So I know that kind of contradicts what we said last class, but we need to put that in our brain now, is that it is okay to cross or touch a horizontal. It's not okay to cross or touch a vertical because it's physically impossible in math. And then we also want to find that y-intercept, plugging in 0 for x. That would be 0, 1 over 9. So again, right above that x-axis, or x-axis here. So let's think about what needs to happen here. Specifically in this middle region, I have the x-intercept and I have the y-intercept. There's only a couple things that could happen. Well, the first thing that I could do is I could go to touch this point and come back down and go to this asymptote and go to this asymptote. That's not an okay thing because I am creating a x-intercept that is not there. So that's wrong. The only other thing that could happen is if I go up and approach this vertical asymptote and I go, well, actually there's another thing. I could go up and approach this asymptote. That's also wrong though, because if that was the case, this x-intercept would have a squared factor there. And that x-intercept doesn't have a squared factor. If this would have been squared, then this is what our graph would look like. But it's not squared. Therefore, shouldn't have done that. There. Therefore, our graph doesn't go that way. So the only other option is to go down and approach the other vertical asymptote. Kind of reminding me of that cubic function, how it kind of does that wiggle and that point of inflection there. Okay, so then we have to think about what's happening on the left and the right of those two vertical asymptotes. Well, again, let's think about squared factors. We don't have squared factors anywhere in this problem. Therefore, we are not going to approach vertical asymptotes together. So that only leaves one thing. That only leaves us going away in different directions. Okay. You also don't want to just cross the horizontal asymptote just because you can. I know that I'm not crossing it here because, again, I would be creating an x-intercept that's not there. So we're always going to approach those horizontal asymptotes unless we have an x-intercept there or we know we have to cross it for some particular reason. Other than that, we want to stay away just like normal. What I also want to talk to you about is, because this can get a little weird because there's so many different things that can happen, you can also do like a sign test. What does that mean? Well, you could pick some numbers from this side and pick some numbers from this side and plug it in to see what it gives you. And really, you don't have to worry about the number because the numbers are going to be ugly, but all you have to worry about is the sign, whether it's going to be positive or negative. For example, if I plug in -6 into this equation, -6 would be -6 minus 1, which is going to be a negative number at the top, divided by -6 plus 3, which is also a negative number, times -6 minus -3 is also another negative number, which means we have a negative divided by a positive, which is a negative. So when x is -6, the y value is negative. Well, that means we did this right because we're in the bottom half. We're in the negative realm. I could also plug in something like positive 6. So when I plug in positive 6, I get 6 minus 1, which is a positive number, divided by 6 plus 3, which is a positive number, times 6 minus 3, which is also a positive number. Well, positive divided by a positive is a positive. And when x was 6, I was in the positive region. So that means I did it right. Okay? Notice again, I'm not worried about the actual value. I'm just worried about whether it was positive or negative because that's all I need to know. All right, let's try it again. This time, we don't need to factor our numerator, but we do need to factor our denominator. So, I have 5 over what are factors of negative 12 that add up to negative 1? Negative 4 and positive 3. So that means my vertical asymptotes are going to be at x is 4 and x is negative 3. So I'm going to go ahead and plot those asymptotes now. So negative 3. And I kind of got tired of switching back and forth from that dotted line, but probably should keep it going if you have started just so it's nice and consistent. Horizontal asymptote, I compared the degrees. It is bottom heavy, J low, Y equals 0. Okay. X-intercept, set your numerator equal to 0. That's physically not possible, so there are no X-intercepts. And then Y-intercept, plug in 0 for X, and what are you going to get? You're going to get negative 5 over 12. 5 over negative 12, negative 5 over 12, whatever, same thing. So when I go to plot that, that's going to be almost at negative 1/2. So right there below that X-intercept, oh my God, right below the horizontal asymptote. Oh, sorry. So here again, we have this middle region, the left region, the right region. All we know is that that Y-intercept is at 0, negative 5 over 12. Well, because I have no X-intercepts at all, that means I only have one option: to go down and approach that vertical asymptote and to go down and approach that vertical asymptote. This is okay to do because we don't have a squared factor, because that point that I'm quote-unquote bouncing at is not an X-intercept. It is just the Y-intercept. So that's okay to do. If that point would have been on the X-axis and we bounced, then we definitely would have wanted to see something like this. But that wasn't the case. Okay. So then I also want to think about, are there any squared factors at all? No. So because there's no square factors, I do not want to approach those asymptotes together. I want to go in the opposite direction. So I'm up here and I'm up here. If that doesn't sit well with you, or if you can't remember that or think about that, plug in some values. Plug in your negative 6. See if you get a positive or a negative number. Plug in 10. See if you get a positive or a negative number. You are going to get positive for both of those, which then confirms that we graphed it correctly. Okay? And like I said earlier, the more practice you get, the more exposure you have to all these different types of rational functions, and so the more confident you feel. Factoring again. I told you got to know how to factor. All right? When I factor this one, I actually get a GCF of 2, leaving me with x squared minus 2x plus 1, which is actually a perfect squared trinomial of x minus 1 squared. So we do now have a squared factor, so that's going to affect something. And then in your denominator does factor into x minus 4 and x plus 2. And so let me go ahead and erase this and move this over here just to make my life a little bit easier. All right, so now that we're factored, we can find our vertical asymptote, setting our denominator equal to 0. X is 4, x is negative 2. So we have, again, 2 vertical asymptotes. Negative 2, positive 4. Okay. Horizontal asymptote, we want to compare the degrees. The degree of the numerator's 2, the degree of the denominator's 2. Because they're equal, we compare, or we divide our leading coefficients. 2 divided by 1 is 2, so the horizontal asymptote is at y equals 2. Okay. X and Y intercepts. X-intercept, set your numerator equal to 0. So that means I'm going to have one at 1 comma 0, but remember that was a squared factor. So remember what happens when we have a squared factor for our x-intercept. It's going to bounce there. And then our y-intercept, we plug in 0 for x. So plug in 0, 0, 0, 0. So I basically get 2 divided by -8, which I know is -1/4. And so if I plot the 1, 0, I know I'm going to bounce there. And if I plot the 0, -1/4. 0, -1/4 is about right there. So that also confirms that I'm going to bounce downwards. Okay, remember, don't cross that horizontal asymptote unless you absolutely have to. The x and y intercepts led me to bounce and go downwards towards those vertical asymptotes. There was no other squared factors, which means I go in opposite directions of that vertical asymptote. So I'm here and here. And the last one. Factoring, the numerator is already factored. The denominator, I'm just pulling out the x. So my vertical asymptotes are at 0 and -4. So at -4 and on 0. Horizontal asymptotes, it's bottom heavy. So y equals 0. Okay. X-intercept, setting that numerator equal to 0. It is on the horizontal asymptote again. So I know I'm either touching it or crossing it. And I know that I'm actually going to cross it because I'm not going to bounce there because it's not a squared factor. There are no squared factors in this rational function. So no bouncing and no tangent or togetherness at those asymptotes. And then the last thing is the y-intercept. If I plug in 0 for x, 0, 0, 0, I'm technically getting -3 divided by 0. -3 divided by 0 is undefined. That means there is no y-intercept, which makes sense because I have a vertical asymptote there, right? I have the vertical asymptote on the y-axis. That's where all my y-intercepts would live. So it's not there. Not there. Vertical asymptote. Okay. So let's think about what's happening here. The only real piece of information I know is that I have an x-intercept at 3, 0. So I don't know if I'm crossing and going down here or if I'm crossing and going up here. So this time I actually really probably need to do a little sign test, okay? And I'm only really going to worry about the left and the middle because once I know those two, the right should be fine because I don't have any squared factors. So I know I will be going away from the vertical asymptotes. So I'm going to pick something like maybe -10, and then I'll pick maybe like -2, and then that will tell me where I'm at on the graph. So when I plug in -10 into x, I get -10 minus 3, which is a negative number, divided by -10, which is a negative number, times -10 plus 4, which is still a negative number. So that's negative divided by a positive, which is a negative value. So at -10, it's negative. So that means I'm approaching those vertical and horizontal asymptotes down here. When x is -2, I have -2 minus 3, which is a negative value, divided by x, -2, which is negative, times -2 plus 4, which is positive. Well, this gives me now a negative divided by a positive. I'm sorry, negative divided by a negative, which is positive overall. So when x is -2 in this middle region, it's going to be positive. So that means I need to do something like this. I cannot create an x-intercept that is not there. So I have to stay all positive in this middle region. Now, we don't know how far down or how high up that point is. So if you wanted it to look something like this, that's fine. If you want to go as close as you can, that's fine too. If you really want to stay close to those asymptotes and kind of do this little thing, that's fine. Just make sure that these aren't pointed corners. That's fine, but we're sketching here, okay? There's no way that we can get so accurate like that. But I need to see it in that realm. So this now tells me, because there's no squared factors in the denominator, I'm not going to be up here. I'm going to be down here. I have to cross, but I'm still approaching that horizontal asymptote, okay? So, I don't know why I just erased that. I can leave that. Okay, so what I want to do really quickly is at the very end, just talk about the steps that we have been doing this whole time. First step is always factor. Factor the top and the bottom when necessary, okay? Sometimes it's already factored. If it is, great. Second thing we need to do is find the asymptotes. Let's talk about the two different kinds. You have vertical asymptotes where you're setting your denominator equal to 0. So remember, vampires live in the basement, if that helps you out. You also have your horizontal asymptotes where you're comparing degree of top and bottom. And then three things could happen. If the top is bigger than the bottom, you have no HA, maybe a slant asymptote. We'll talk about that tomorrow. If your top degree is equal to the bottom degree, then you're going to say that that is the leading coefficient divided by the leading coefficient. And if your bottom is bigger than the top, your bottom heavy, J low, Y equals 0. Okay? The next thing you do after that is you find your intercepts. Again, two scenarios. You have X-Intercepts where you set numerator equal to 0. And you have Y-Intercepts where you plug in 0 for X, which is really just looking at constant divided by constant in standard form. Okay. So that's your steps of what to do. And then after that, obviously, you're graphing if needed. All right, guys. Practice, practice, practice. See ya.